So particle motion for for AP calculus AB, we have this position function. What we have is we have a horizontal line, and we have this little tiny, particle. Here's our particle. Has pink eyes. Our particle moves left. Moves left and right, but we don't know how far or at what velocity. So we have this question. We say find the velocity of the particle after 2 seconds. So start by doing this. Find the velocity. Find velocity v of t after 2 seconds. So start with the idea that if this is position right here, then the first derivative of position is velocity. So we can say that velocity is equal to the first derivative of position. So the first derivative of this function is not t squared minus t, but 2t minus 1. So this is what I just did, Austin. This 2 right here, I brought it down to here, and then I decremented this exponent, just decreased it by 1, and that's how it got to 2t. And then the first derivative of this thing right here, there's a 1 here, be 1 times negative 1 is negative 1, and then it would be t to the 1 minus 1, so t to the 0, and t to the 0 is 1. So there's that. So we want to know what's the velocity after 2 seconds. So what we want to know what is the velocity after 2 seconds. And the velocity after 2 seconds is 2 times 2 minus 1. So the velocity of our little guy up there after 2 seconds is 3, isn't it? Oh, and it's actually 3 feet per second. So the next part of the question would just be this, which is what's the acceleration? So what's the acceleration? So 2. What's the acceleration of the particle after 2 seconds? And we know this. We know that the first derivative of position is velocity, and the first derivative of velocity is acceleration. So acceleration at any given time is equal to the first derivative of velocity or the second derivative of position, and that is just 2, because what I'm doing here is taking the first derivative of this, and derivative just means slope, and the slope of this line is 2. So we have that. The next question we have is, when does the particle change directions? Well, we know the particle changes directions before it can change direction. Look, take something, throw it up in the air. At some point, it's up in the air, isn't it? It has to stop. Right, if it's going to come down, it has to stop first, right? So it goes up, it has to come to a full stop, and then it changes direction coming down. Well, this particle is the same way. So if the particle was moving to the left, and then later we find it's moving to the right, it had to stop first, didn't it? So what you do is you take velocity, so you take v of t, velocity, which is equal to 2t minus 1, right? And then you just do the algebra. You say, when is its velocity equal to 0? So when is this equal to 0? And if we just do the algebra here, we add 1 to both sides, don't we? And we get 2t is equal to 1. So when t is equal to, now divide both sides by 2, right? So when t is equal to 1/2, the particle stopped moving. And then when it stopped moving, then it could change directions, right? Think about this for a second, Sky. If you're going this way as fast as you can, and then all of a sudden you're going this way, you had to stop first, didn't you? You're going this way, you had to stop to go that way, right? So that's how we figure out when this particle stops, when it changes direction, it has to come to a stop first. So at t equals 1/2, so 1/2 second after it starts. All right? All right, I'm going to do part 2 to this video in just a second.